This lesson is on zero and negative exponents. So it shows you how to handle a power with an exponent of 0 and a power with an exponent that's negative. So let's start with 0 as an exponent. So anything with an exponent of 0, doesn't matter what the base value is. Remember, a power is made up of a base and an exponent. So this is n to the 0th power. Anything with an exponent of 0 is equal to 1. So 4 to the 0th power is 1. Negative 3 to the 0th power is 1. 5.12 to the 0th power is 1. Anything to the 0th power is 1. All right? Now, negative exponents. So, in general, we don't like exponents negative. In some of the problems you're going to encounter, you will end up with a power with a negative exponent. And so whenever that happens, we want you to rewrite it with a positive exponent. And the way you do that is by basically taking the reciprocal of the power. So n to the negative second power is equal to 1 over n to the positive second power. So here's another example, 7 to the negative third power. So if I want to rewrite that with a positive exponent, I would just put it under 1. So in other words, you can think of this as 7 to the negative third power over 1, and you're going to flip it over. That's why I say the reciprocal. So if you flip it over, then it becomes a positive power. Negative 5 to the negative second power would be 1 over negative 5 to the positive second power. Now, what if you had 1 over 2 to the negative third power? So what if it's already under 1? Well, what's the reciprocal of that? Flip it over, and it becomes a positive exponent. And I don't need to write that over 1. So basically, if you move it from the numerator to the denominator, or from the denominator to the numerator, the sign of the exponent flips. All right? So just to show you the flip side of what I was doing here with that 1 over 2 to the negative third, if you had 2 to the negative third and you wanted to make it a positive exponent, you would move it under 1. And then it would become a positive exponent. So if it's already under 1, move it up to the top and it becomes positive. If it's over 1, then move it to the bottom, to the denominator, and it becomes positive. So you can change the sign of an exponent by moving it from the numerator to the denominator, or vice versa, from the denominator to the numerator. All right, so let's look at some more of these. So what is a simplified form of each expression? So when we talk about simplifying, like I said, we don't like to leave powers with negative exponents. So 9 to the negative second power, to make that a positive exponent, we just put it under 1. And so it'd be 1 under 9 to the second power. And then we could simplify that even further by going ahead and doing 9 to the second power and getting 1 over 81. All right, negative 7 to the 0th power, anything to the 0th power is just equal to 1. 6 to the negative first power, so let's make it a positive exponent. So that's 1 over 6 to the first power, so move it from the numerator to the denominator. And 6 to the first power, anything to the first power, is just equal to itself. And then negative 4 to the negative second, so put it under 1, becomes a positive exponent. Since there's parentheses here, that means the base is negative 4. So that's negative 4 times negative 4, so that would be positive 16. So an algebraic expression, like I said earlier, is in simplest form when powers with a variable base are written with only positive exponents. So we don't like to leave expressions with negative exponents. So we're going to simplify each of these expressions, and basically just means we want to take any negative exponents and make them positive. Now, one thing I need to clarify, a lot of times my students think this 5 is attached to this a to the third. So they think this is one thing, 5, a to the third. And it is not. That's a 5, times an a to the third times b to the negative 2. So everything here is in simplest form except for the b. So it's just the b that we need to move down to the denominator. So what we get, leave the 5 and the a to the third in the numerator and put the b in the denominator. And that's it. That's all you have to do. All right. Again, if it's in the denominator, then move it up to the numerator. So to make this n a positive third, we move it up to the numerator. And I don't need to write that over 1, so I'm just going to simplify it to n to the third. All right, so again, none of these things are connected. These are all separate things. This is a 4 times c to the negative third times b. The 4 and the b are fine. It's only the c that needs to get moved down to the denominator. So I'm going to leave the 4 and the b in the numerator and move the c to the denominator and change the exponent to positive. So once you get it simplified and you don't have any negative exponents, then you're done. All right, so in this one I have a 2 in the numerator. That's fine. And a to the negative third in the denominator, so I'm going to move this up to the numerator. So I would have 2a to the positive 3 over 1, which is the same thing as just 2 times a to the third. All right, last one here. The m is in the bottom, and it's got a positive exponent, so it's fine. So I don't want to move that. I'm only moving the negative exponents. So this one gets moved down to the bottom with the m. So now I have m to the second times n to the fifth. So the n was up in the top in the numerator, and I moved it down to the bottom. All right, one last piece here. Evaluating an expression. So we have this expression, and they want us to evaluate it if s equals 2 and t equals negative 3. So what I want to do is first rewrite this expression like we did on the last slide, getting rid of any negative exponents, and then we'll substitute in. So this t needs to get moved down to the bottom. The 3 and the s to the third are fine. I just need to move the t. And so that's going to give me 3 times s to the third over t to the second. And now I'm going to substitute. Substitute. So I'm going to substitute s equals 2 and t equals negative 3. So now I'm going to have 3 times s to the third, that's 2 to the third, over t is negative 3. These parentheses are important because the base is negative 3, so I need to put the parentheses around the negative 3. So that's going to be negative 3 times negative 3. So now you want to follow PEMDAS, and so order of operations says do exponents first. So I'm going to do this 2 to the third. So it gives me 3 times 2 times 2 is 4 times 2 is 8. And I can do this one at the same time. Negative 3 times negative 3 is positive 9. Go ahead and multiply the top. 24 over 9. Simplify it if you can. You can't. They don't have any common factors. And it's okay to leave it improper. So you can leave it as 24/9. All right, so that's negative exponents and 0 exponents. So I hope that was helpful to you. If so, give it a like and a subscribe. And feel free to leave me any comments. Until next time.